Hello, Algebra 1 class. Today you're going to learn about writing equations from either graphs or points and different forms of equations of lines. Go ahead and try this warm-up. One note is problem number 1. It says write an equation that models this situation. To be more specific, write an equation that models the amount he owes, your y variable, as a function of the number of weeks, your x variable. Go ahead and try it now. Pause the video. Okay, here are your answers. So in the first problem, he starts with $75 and he's paying back $5 every week. So if x is the number of weeks, for every week he subtracts $5 from what he starts from, and that's how much money he has left. So you can see this is a linear equation. Your slope is -5 and your y-intercept is 75. Maybe it would be easier to see if we wrote it a little bit differently, and the y equals mx plus b form. I just switched it around. Okay, in the next problem, you just have to subtract the 5x from both sides, and you have y equals -5x plus 8. Or of course you could write it as y equals 8 minus 5x. The last thing, you have to find the slope. So the slope is easier when you have a graph because you can just look at your change in y over your change in x. Here I wrote down the formula for you. So you want to take one point's y, subtract the other point's y, and then starting with the same point, take and subtract the two x's. So it doesn't matter which one is point 1 or point 2. I made the first point be point 2 and the second point be point 1. So I did 6 minus 8 divided by -5 minus 0. Just remember, it's always the difference of the y's over the difference of the x. Then I write it out. Make sure you always write it out. And you get -2 over -5. And of course, a negative over negative is +2/5, a positive slope, meaning that the line is increasing between these 2 points. All right, when we're writing linear equations, we have 3 different forms of a linear equation. Your slope-intercept form, which you're already familiar with, m is slope, b is y-intercept. Your standard form, which a lot of times you have to solve for y to find your slope and y-intercept. Sometimes I call this intercept form because I can quickly plug in x of 0 and find your y-intercept, c over b. Or plug in y of 0 and find your x-intercept, c over a. And then we have this new form, which you guys are probably not familiar with, called the point slope form. Let me write that down. That is y minus y1 equals m slope times x minus x1. Now, you might ask, why do I need another equation of a line? Well, this one turns out to be really easy to write equations from graphs or from points and slope. Now, the information in this one is you're given your slope. You have to have your slope. And you have to have a point. And the point, we'll call it x1, y1. So you're going to just plug in x1, y1, and the m into this equation and then simplify. And you'll see an example or two. All right, just for a little review, we're going to write an equation using slope-intercept form first. So this is your y equals mx plus b form. Let's just go through these. So you have a slope of -2, that's your m, and a y-intercept of 5, that's your b. So in this case, you just write it down. Y equals mx, don't forget the x, plus b. So I just substituted in the slope and the y-intercept. Same thing here, y equals 3/4 x, don't forget the x, minus 3. All right, this one's a little bit harder. Here you have 2 points. So we don't have the slope, do we? So the first thing we have to do is calculate the slope. M equals y2, we'll say that's -5, minus y1 minus -1. I always write it out so I don't make a mistake in my head. And then the x2, we're going to call this the x2 and the y2. We could have switched them, it doesn't matter, as long as we're consistent top and bottom. So x2 minus x1. And then we simplify. Negative 5 plus 1 is negative 4 over negative 3, and that is positive 4/3. You can always graph it real quick and make sure your slope looks right. 0, negative 5 is down here. We'll call that point A. And 3, negative 1 here. Call that point B. You can see this line is increasing, and we have a positive slope. All right. All right, so now we're going to do some examples using that new form called point-slope form. So here, once again, the point-slope form of an equation of a non-vertical line. So that was important that I didn't mention before. So not a vertical line. It will work for everything else. Through a given point, so you have to have a point with a slope. And then you plug those values in for the blue slope and the pink or the red point, and you have your equation of a line. Once you have it, then you can simplify it for y equals and put it in slope-intercept, or you could also put it in standard form. All right, let's go through an example. Let's move it up here. So here's our example. So we're going to write y minus the y coordinate equals the slope 3 times, parentheses are important, x minus the x coordinate. Now that's going to turn into x plus 2. It's always kind of the opposite of the sign in the point. But let's simplify this. Y minus 6 equals 3 times x plus 2. Now I'm going to distribute the 3. And then I'm going to add the 6. And I end up with y equals 3x plus 12. And we could graph it to make sure we're right. You know, if you plot that and then walk the slope, you will get this line. All right, let's do it again, but this time now you don't have the slope. So we first have to calculate the slope. So I'm going to make this my y2. 5 minus negative 1 over the x2 minus the x1. So just be consistent. Up and down should be 1 point, yx, yx. All right, so we simplify. We have 6 over negative 2, which is negative 3. All right, now I'm ready to do point-slope form. All right, so I have a slope, and I can pick either this point or this point. It's your choice. You will end up with the same linear equation regardless of which one you choose. I think I'll choose this one. So y minus the y equals the slope times x minus the x. And we're almost done once we distribute and solve for y. So we have y minus 5 equals negative 3x plus 6. So we're going to add the 5 to both sides. We end up with y equals negative 3x plus 11. And that is our equation of our line. Pretty easy. Now you should go ahead and try to do both these problems on your own. Feel free to go back, or hopefully you've been taking good notes throughout. Go ahead and pause the video here, try them on your own. All right, and here are your answers. Just a few notes. When I wrote this one down here, I just quickly wrote y plus 1, which is really y minus negative 1. So I just changed the sign there. And this one, of course, is x minus 3. When you distribute, don't forget negative 2/3 times negative 3. Negative times a negative is a positive. And 2/3 times 3 is 2. And then, of course, we subtract the 1 and get plus 1. Over here, I did 4 minus 7 over negative 3 minus negative 2, which is a plus 2, and got negative 3 over negative 1, or 3. And then I picked which point. Let's see, I chose this point. It didn't matter which one I chose. So y minus 7 equals 3x minus negative 2. Distribute, and then add the 7. And there's your answers. Now what we're going to do is write the equation of lines from a graph. And we can do this in point-slope form, or if it's easy enough, we can do it in slope-intercept form. So I'm going to start with the blue line. And notice this one, you can see the intercept right there. So that does make it significantly easier. And I just need to find out what my slope is, and then I can write my equation. So my slope, I'm just going to take 2 key points here, and then I'm going to walk left to right. So I say, is it up or down? Oh, it's up 4. So slope is plus 4, and then over 1. So my slope is 4. And then I can see that my y-intercept is also 4 because that's where it crosses the y-axis. So the equation on that line is very easy. It's 4x mx plus b. There you go. Okay. Now, in the red line, I would like to do that too, but can you tell what that y-intercept is? I certainly can't. So what I'm going to do instead is pick 2 points on the line that I can clearly see. And it looks like I have one here. This is 5, -1. And I'm looking for another key point here. Oh, up here. I got one here, or I got one here. I think I'll go with this one right here. And this is -4, +5. Okay, using those, I'm going to use point slope form. First thing I have to do is find the slope. M equals 5 minus -1 over -4 minus 5. And I end up with 5 plus 1, or 6, over -9. There's a common 3, so that's -2/3. So I can see my slope is going down 2 over 3, down 2 over 3, down 2 over 3. I might have been able to figure it out that way too. Okay, but now I got to write the equation of the line. So I'm going to use point slope form. And I can use either of these 2 points. I think I'll choose this one. Okay, so y minus -1 equals my slope times x minus 5. Now this one's going to be a little harder to simplify because you got some fractions, but let's just go through it. Distribute, you get -2/3 x, and then negative times a negative is plus, and 2/3 times 5. Think of that as 5 over 1, so that's plus 10/3. Okay, good enough. Now I have to subtract the 1, so we end up with y equals -2/3 x. Once you find the slope, it doesn't change. And then we have 10/3 minus 1. So 10/3 minus 1, which is 3/3, is plus 7/3. And that is our equation of a line. So let's look now. 7/3, that's about, what is that going? Twice and 1/3. And if I look at that intercept right there, 1, 2, and 1/3. Now, maybe you could have eyeballed that. I certainly couldn't. So it's good to have a way to write an equation of a line. Okay, so I think now that we've done an example from 2 points and from a slope and a point and also from a graph, I think that's a good stopping place for now. I will be recording a second video that does some more examples with applications that you should look for next.